Okay, now if we want to write this algebraically, and also the reason why we're going to talk about this algebraically is because we want to actually graph it. Now, here is an algebraic definition. I'm going to move my next bit down a bit. Algebraic definition of what the absolute value symbol does. So for any real number x, the absolute value of x is x for any number x greater than 0. So you remember this is a piecewise function. It gives us the stuff on the right tells us the conditions for x, and the thing on the left tells me what happens for those conditions. So here, let's have a look at this. For any real number x, define absolute value of x as equal to x for x greater than or equal to 0, and negative x for x less than 0. Now this hopefully should make sense. The reason being is, let's have a look at the first line here. If x is a positive number, then, which is what this condition is telling me, so for x greater than 0, which is just means x is a positive number, if we chuck x into our absolute value sign, so for example, let's chuck in an absolute positive number, let's say 100. If I chuck it into my absolute value sign, that's just going to give me the original number. So here, if x is just a positive number, the absolute value of x is equal to x, if x is a positive number. Now the second condition is for when x is negative. Now if x is negative, what happens? Well, let's do another example. If I do x's absolute value of negative 100, that will still give me 100. That will still give me 100. But the way that you can think of this is just negative 100, which is your original number, which is 100. So if x is a negative number, it actually takes the negative version of that, so it flips it so it goes back to positive. So that's why if absolute value of x is equal to negative x, if x is a negative number. That's what this definition, algebraic definition, tells us. If x is a positive number, it will just give me that original number. But if x is, the absolute value will give me that original number, excuse me. But if x is a negative number, it's actually going to flip it and give me the negative version of that negative number, which will just end up being positive. So that's what this definition is telling me. And what we can do with this definition here is we're able to actually graph or draw this graph on a Cartesian plane. And so when we graph the absolute value function, it actually gives me this shape here. It looks like a big V. And the reason for that is, let's just have a look at my conditions here. Let's have a look. So for when x is greater than or equal to 0, which is this first condition, so that is on this side here. This side of the y-axis is x is positive. So x is positive on this side. The graph is just y is equal to x. Or the absolute value will just give me x, which is what this side of the line tells me. This equation, this line here, is just y is equal to x. I don't have any points here. If you wanted to, you could probably put on a few points. Let me just move it down a bit so it lines up with my grid, just to show you that. So here we have 1, 2, 3, 4, 1, 2, 3, 4. And if you have a look on my grid, it actually matches up and we've got y is equal to x. So when x is positive, the absolute value graph just looks like a y is equal to x graph, which is a straight line. But when x is negative, so x is less than 0, which is this side over here. So let me write here. So x is negative. I'm just going to specify here x is greater than or equal to 0. X is less than 0. What does the graph look like? Well, this graph over here is just negative x. This graph here, oh, let me try that again. This graph that we've drawn here, that is just y is equal to negative x. So our graph of the absolute value of x is actually kind of made up of two arms that form this V shape. The positive side is just the positive values of x, so positive values of x, so y is equal to x. And the left-hand side is our y is equal to negative x. And so what we have here is, let's actually, the absolute value graph of x. It's made up of two arms and they have those two equations, which is what this algebraic definition is. Now what we want to also look at is the domain and range of x, of our absolute value function. So let's look at the domain. The domain is just which values of x this exists for. Well, if you have a look along my graph, it's going to exist for all values of my x. above the x-axis, there's always going to be one value, or at least one value for each one of my, for this absolute value. So for the domain, we've got negative infinity, infinity. Okay, so that's the domain. How about the range? Well, if you notice, the graph doesn't go below the y-axis. There's no graph underneath the y-axis. So for the range, we've actually got, it goes from 0, which is this lowest point in the middle at the origin, all the way to infinity. So our domain of our absolute value graph is from negative infinity to infinity, and our range is from 0 to infinity. So that's what this absolute value graph looks like.